So, as you said, we'll go through today a full featured presentation of the VMB plugin, and I'll do the presentation mainly in this PowerPoint, and we'll see a live demo of the software while I will answer the questions after this presentation. The OpendTect PSDM VMB system was developed in a multi-client sponsored project between 2006 and 2009, which was the year of the first commercial release. It is available as a set of closed-sourced plugins on top of OpendTect. The VMB plugin is developed and maintained by DGB, while GeoKinetics provides PSDM Kirchhoff and PSDM tomography plugins. OpendTect VMB alone is designed in such a way that any other PSDM platform can easily be linked, in such a way that the interfaces are in the open source part. The model is the following. You have the OpendTect interpretation system, which is the open source software on which the VMB plugin is attached. And from this VMB plugin that reads in the OpendTect data store, there are direct links to the vendor INP company plugins and their own data store. And one of them, but that is only a current example, is the GeoKinetics data store and software, where they are running their tomography and Kirchhoff depth migration solutions. So the PreStack data, if I summarize, can either be stored in OpendTect format or in the vendor's own format. OpendTect supports direct data access from PreStack SEG-Y, and each company can either commercialize their plugins or keep them proprietary. Let me give you now an overview of the VMB plugin. With the VMB plugin, you can pick velocities from migrated gathers in time or depth domain. You can use the picked velocities to generate a new velocity volume, and you can finally refine an existing velocity model or a picked velocity model using space-limited additions and smoothing. What you can do as an alternative to this, you can use the VMB plugin to pick PreStack events for an update of the velocity model by grid-based tomography. And you can also update the move-out correction of your PreStack gathers using the corrected velocity volume. What I will call a velocity model in this presentation is any set of velocity and anisotropy parameters. Velocities can be extracted from the data, so used as input to the semblance calculation, while the anisotropy parameters are painted. The picking is assisted by the following tools. It is assisted by a user-defined laterally variable mute functions. You can use pre-processing methods that they are designed on the fly and applied on the gathers before the semblance calculation. You can do semblance trackers and track your PreStack events. You will also be able to display in this plugin an on-the-fly display of the new velocity model while it is being created, and you will get an on-the-fly display of the PreStack events in the 3D scene of OpendTect. I'll give you examples of all of this. A typical workflow starts with data loading. You will have to load your PreStack data. You migrate in a form of migrated gathers from SEG-Y volumes, or using links to existing softwares like GeoFrames, Arnaud Huck, and Petrel. You can also load similarly the velocity model from either SEG-Y volumes or the software links I mentioned above, or from ASCII velocities in XY depth velocity format, for instance. The data loading of the PreStack SEG-Y can be done in two modes. Either you can translate your SEG-Y gathers into OpendTect format, or you can read them in place. And in order to do this, we have what we call an indexing of the PreStack SEG-Y gathers that is entirely scalable, and that allows a very fast access to any size of data store. So it is just as quick to browse 5 GB of gathers or several terabytes. The data loading will continue with the loading of the velocity model, similarly using SEG-Y files or using ASCII velocity functions. That is such an example where you see here the main import window where you browse and get your input ASCII file. It needs to be specified with respect to positions, so X, Y, and depth values, or inline, crossline, and depth values, either in milliseconds or in meters or feet, and velocity values. In terms of velocities, you can input RMS velocities, you can input interval velocities, or average velocities, regardless of the domain. Only the RMS is not available in depth surveys because it is not doesn't exist as quantity. After the data loading, you'll need to perform a number of data preparation steps that are specific to the VMB workflows. You'll need to grade your velocities from a coarse volume or from your picked functions into full resolution velocity volumes, and that is because the VMB plugins need a velocity trace for every gather of the PreStack data store. You also need to be able to scan the velocity volume in order to automatically extract the time range and depth range that correspond to your stored velocity amplitudes. Also, we give you a conversion tool that allows you to convert between the different velocity types you can have. So, for instance, if you have an RMS velocity volume, you can convert it back and forth into an interval velocity volume. This is an example of, for instance, velocity functions that were imported from an ASCII file and graded into a full resolution velocity volume. And the velocities are here color-coded and displayed with partial transparency on top of the seismic data. And in order to do this, we use the volume builder tool that has been presented at the previous webinar in November. The data preparation is also consists, as I said, of the velocity conversion tool. That is a very simple window where you will input your velocity model. Here I have a volume containing RMS velocity values, and it is converted using this conversion tool into an interval velocity volume. This conversion is only made available for use in your interpretation. As such, the VMB plugin does not require you to do the conversion because the VMB plugin can use just as easily RMS velocities or interval velocities. Once you have loaded your data, you'll be able to display it in the 3D scene, as you can see here, by popping up a number of PreStack gathers on perpendicular vertical slices of your data. So here you're looking at an inline of full stack data where I have added one perpendicular slice of a gather at this CDP location. What you can do in this scene of displaying multiple gathers, you can also do in a 2D viewer now, and that is a new function available only in the current development release 4.3. In this multi-gather display 2D viewer, you can choose to display either different positions of the same PreStack data store, or you can also display different PreStack gathers in this 2D viewer. And that is only for displaying the data as it has been loaded from the input file. The typical workflow continues after the data loading with the velocity picking step. This velocity picking step comprises either the vertical velocity analysis that includes picking and setting up a mute function. It includes designing the set of pre-processing methods, and it also includes the semi-automated picking of the velocities, the anisotropy functions, or the picking of the PreStack events. Alternatively, or I would say in addition to the picking in the vertical velocity analysis window, you can also use an horizon consistent picking mode that allow you to pick velocities on entire inlines or crosslines very quickly for a number of horizons. In order to do the picking, a semblance will be computed with a varying number of move-out corrections, and before the semblance is computed, you need to specify a number of pre-processing methods. So you can you'll input your mute function and AGC and supergather pre-processing before the actual semblance is computed. Once the pre-processing is done, so in this case mute and AGC, we have developed a factory that allows any software vendor to do their own semblance computation from the OpendTect PreStack data, migrated PreStack data. So in the default case, you'll always have at least a cross-correlation based semblance computation and a simple stack of the data for varying move-out corrections. The velocity picking window is looking like this. On the left-hand side, you'll see your migrated gather, and that is a strong requirement of this plugin. You need to input migrated PreStack data. The data can be either in the time domain or in the depth domain, but it has to be at least migrated. If you are working in the time domain, you can input either NMO-corrected gathers or un-NMO-corrected gathers. But if you input NMO-corrected gathers, you'll also need to provide next to the PreStack data store the velocity volume that has been used for the migration. And this velocity volume will be displayed on the right-hand side with this curve view, and that is something that will also assist you in the picking of the new velocity model. So what you see in this window, so on the left-hand side, if I summarize, you see the migrated gathers for one CDP location with eventually the picked mute function that is a laterally variable. It's created using inverse distance weighting. And on the right-hand side, you see the velocity function from the migration velocity volume, and you see in color coding here with a rainbow color bar the computed semblance corresponding to the migrated gathers. So as you can see here, this is what you'll use for refining the new velocity function. So each peak here is a new RMS velocity peak in this case because I'm in the time domain, and you get the new corresponding interval velocity function displayed next to the peaks you have made on top of the semblance panel. What you can also use in order to aid your computation is that in time surveys you can provide a corridor, a velocity corridor that will dismiss most of the solutions, most of the unrealistic solutions for the move-out correction. In addition to this picking mode that is gather by gather, you can also use the horizon-based velocity analysis panel that looks like the following panel. The first two displays at the top of this window present one entire inline of your full stack data, or one entire cross line on the full stack data, first in the time or in the normal depth domain, with an overlay here, a line presenting the horizon used for the picking, and you get the same vertical section after flattening with respect to this horizon. Then the third panel in this window is presenting the semblance corresponding to these positions along this post-stack horizon for varying move-out values. And finally, the last set of panels at the base represent a random number of PreStack gathers along this inline, where you can get immediately an overview of the flattened gathers after the application of the existing velocity peaks. what you can also do in the vertical velocity analysis window that you cannot do in the horizon-based velocity analysis, you can also pick your anisotropic parameters. They are the eta function here in the time domain, or the epsilon and delta functions in the depth surveys. And these two are picked next to the velocity, the new velocity function in the vertical velocity analysis window. You can also do, and that is an alternative way to do the update of your velocity model. Instead of picking the new velocity curve here in on top of the Semblance panel, you can also pick the full waveform, the full set of PreStack events on the gathers directly without using the Semblance computation, and these PreStack events will then be exported and made available for the grid-based tomographic update in the vendor software. And then this picking is semi-automated in such a way that you will pick one or more seeds on the event, and then the waveform will be auto-tracked for all the offsets of this PreStack common image gather. What we also provide is a full compatibility of the VMB plugin with the Wacom digitizing screen. That allows you a superior hand-eye coordination and allows an accurate drawing of the mute functions, the residual move-out, so the velocity curves, and the PreStack events. So everything you can pick in these VMB-specific windows can be picked with a pen on a digital screen just as easily, and I would say much more easily than with a mouse on a normal screen. And it's not only an adaptation of the hardware, because also the software has been adapted in order to benefit, to make the workflows benefit from the pen devices. In order to add your interpretation, we provide also a full display capabilities of the PreStack events in the 3D scene. So while you are picking in the vertical velocity analysis window, you will see the PreStack events displayed in the 3D mode, in the 3D scene, and that will allow you to get very quickly an overview of the lateral consistency of your picking while doing the depth interpretation. And if I go on with the typical workflow, after the picking of the velocities, you will perform the building of the new velocity model as such. In order to do the model building, the very obvious first step is to grid the velocity picks made in the VMB specific picking windows, and these picks will be converted from error mode functions into velocity values and will form the new velocity volume in 3D. Once the gridding has been done, you'll be able to edit your velocity model with a number of tools that are either an horizon package update, a body limited painting, or a surface limited filler, for instance. You also get a number of smoothing tools of the velocity model using 2D FFT time slice computation. Finally, you can apply the new velocity model on the fly on sections while updating the picking. And the model building will always finish, and that will only be the very last step after a QC of the new velocity model in the 3D scene. You will perform the batch processing of the velocity model in order to get on disk a volume that you can either use in place as such, or that you can export into a new SEG-Y volume. The grading of the picked velocities is trivial. The only thing that has to be done is to read the velocity picks that have been done and to specify if you wish to pick them using triangulation or inverse distance weighting. For instance, if I do this, I have done this on this example, not for a velocity volume, but for a delta set of peaks. So this was my delta function on one gather of the survey, and because I have done this over a number of gathers of this section, you can on the fly grid the peaks after each peak and get an overview of this 3D field of delta peaks. And that is all done using the volume builder. What you can also do as an alternative to the gridding is an horizon-based painting. So for instance, you can paint a given velocity between a top horizon and a bottom horizon using either a top value and a gradient that is append to the top horizon, or you can go from a top value to a base value. If you don't have any velocity volume, this is the step you can use to create your very first velocity volume by putting a gradient of velocities from the C-band down to the survey bottom, for instance. And that will be more than enough to perform the very fast migration and get the migrated PreStack data that you need in order to do the picking in the VMB plugin. What you can also do, in addition to the horizon-based painting, you can do a similar step that is called a body-shaped painting, where you would input a 3D body, here a salt structure extracted from the ESG SEG salt model, and that is done in order to alter here the velocities inside the body. In this setup, I leave the outside values to transparent, which means that they are specified by either the velocity picking or by the horizon-based painting, for instance. So in general, by whatever step has been defined before the body shape painter. What you can also do, this is a body extracted from an existing velocity model. What you can also do, you can, for instance, train attributes and neural networks in order to extract the velocity bodies from the full stack seismic data. So that is done using neural networks when it comes to the extraction of the sort probability volumes, and the body as such is extracted using implicit representation in OpendTect. Finally, in order to add it to the final addition steps of the velocity model, you can do a smoothing of the model by doing a smoothing and average filter. Most often you would smooth your input model with a step out that is at least equivalent to your migration aperture. And this is, for instance, a lateral averaging of 1000 meters per 750 meters. Time slice by time slice. Finally, you have one more addition capability that is called advanced painting, and this function improves the volume builder functionalities. For instance, if you have velocities that is graded, velocities will be always graded as slowness, and picked delta and epsilon functions are graded as interval quantities in depth surveys, and eta is graded as an effective quantity in time surveys. Advanced painting can be done using the surface limited fillers that are presented on the next slide, and also several volume builder setup can be added on one slice. This is something you can use in order to either compare several velocity models on the same inline or cross line, but you can also use it in order to load the graded velocity model on one slice, the graded delta field on a second slice, and the graded epsilon field on a third slice, third layer of the same slice. And then you can toggle very easily on and off between these various slices. The surface limited filler is yet another volume builder step that allows you to do some more, that gives you some more editing capabilities of your velocity model. it will paint velocities within an area defined by one or more surfaces. And by here I mean surfaces in a very large context, because you can specify, for instance, one surface as the top boundary, one surface as the base boundary, and a third surface as a bounding fault with respect to this given compartment. And within this 3D area, you will paint velocities either from a constant value or from stacking velocities extracted or stored, at least stored along a 3D horizon. And from this horizon, you would paint either a gradient of constant values, or once again a gradient that varies laterally and stored as such as horizon surface data. The final steps of our typical workflow would be to run the new Kirchhoff migration using the new velocity model, or what you can do alternatively is you can also update the velocity model using a grid-based tomographic update followed by a new Kirchhoff migration. Or I also want to mention that you can also apply the newly created velocity correction, the newly created velocity model as a correction on the gazette without any remigration, only to apply the picked move out on each and every CDP location. Finally, you can use the new velocity model to update your time depth conversion, so to update your depth interpretation. The additional migration can be done for now in the Ethos job deck builder, that is a software by GeoKinetics, where you can apply ray tracing and compute travel times, where you can run your Kirchhoff depth migrations and your grid-based tomographies. Finally, I'll mention a few last things that you can also do. That is one function that you can only do in the OpendTect 4.3 release. You can now apply and unapply NMO corrections in time surveys, and regardless of the status of the NMO correction, you can apply a new velocity model. Also, you have a new angle tool that has just been released, that will be released today in the stable release also, that allow you to compute mute functions that are defined by constant angles, and the angles will be computed from your velocity volume. So in this case, on this CDP gather, I have computed mute functions with a constant angle value of 2 and 32 degrees. So you see the tail mute here equal to 2 degrees that appears here, and the one corresponding to 32 degrees that appears here. And so the two corresponding mute functions are stored on disk as mute functions, and you can use the standard attribute tools, so the PreStack attribute, in order to create your full stack after the application of these angle mutes. So the restacking is to be performed, as I said, using the PreStack attribute, using the PreStack processing methods. So in this example, I have changed the application of the mute function, the AGC, some supergather stacking, and finally, at the end of the setup, the velocity correction. So all these steps are run sequentially on the PreStack data store, and the output of the PreStack attribute will be the new full stack seismic data set, or you can even also do any angle stack, so between 2 and 32 degrees if you input angle mutes in addition to these pre-processing methods. The time depth conversion can be done for volumes and horizons, and that is something you can perform back and forth between times and depth surveys. Most elements, however, displayed in the 3D scene can be visualized on the fly in a new scene before doing the batch processing of your data. Velocity models can be converted, as I said, directly in such a way that you can go in one step from a time domain RMS velocity volume into a depth domain interval velocity volume. So if I would summarize the capabilities of the VMB software, VMB plugin, the open source visualization, storage, and retrieval part is all part of the OpendTect software. The velocity model building plugin by DGP takes care of everything that has to do with picking on your migrated data and creating the velocity model as such. And then the new migration and tomography will have to be done in a second software plugged into OpendTect, so in the Ethos, in the geokinetics Ethos software. We now have a VMB user group that comprises the members of the initial PSDM VMB consortium and the current VMB users. The overall goal is to continue creating the next generation PSDM VMB software by extending and improving the software. Thank you for your attention, and so that concludes the presentation of the VMB plugin. If you have questions, you are most welcome to ask them now.
Well, thank you, Arnaud. It's a very nice presentation. Now, while we're waiting for people to type in questions or raise your hands, there was actually one question asked regarding the horizon-based picking, and they were wondering if there was an automated way to make those picks on the horizons.
For the horizon-based picking, there is no automated way to do the picking, but in general it is from far the quickest way to generate a PreStack function over the entire survey. This is, you see here, the horizon-based velocity analysis window, and what you see already all the data for one entire inline. And the thing is, as soon as you make one pick in this panel, you provide an RMO function for this entire inline. And therefore, from this single pick, you could actually already do the RMO correction on the fly for this PreStack data. So with very few picks, you do provide an RMO function for the entire survey. And then, of course, you'll need to browse through the various sections and see if the RMO function matches your data on all lines, but the number of picks you have to do is rather limited.
Okay, we do have one person who's raising their hand. Marcelo? Marcelo, you're unmuted now. You may ask your question. Marcelo? Marcelo, you might be muted. I see that you're raising your hand. You might be muted on your end. I've unmuted you from my side. Marcelo, can you please try typing in your question? Okay, we're going to give him a minute and see if we can get that typed in here. I don't have any other hands raised at the moment. Well, in the meantime, let me go ahead and start. Oh, well, actually we do. Okay, so Marcelo, I'm going to mute you, so please type in your question if you can. Jafar, I'm going to unmute you. Jafar, you're unmuted. Hello? Jafar? Okay.
Yes.
Okay, yes. Would you like to go ahead and ask your question to Arnaud?
Actually, I do have questions about how we can use the OpendTect software by using a Petrel. A Petrel software also can make a connection between the OpendTect software and the Petrel, if you know about it.
Yes, we have released in June for the first time a link to the Petrel software, and this link allows you to get your data in and out from Petrel. It is a link. You don't have anything more to do on our side than to install the OpendTect software, but you will need to get the Petrel counterpart from the Ocean Store. So without the part from the Ocean Store, you'll not be able to get your data in and out from Petrel. But once you have it installed, you'll get, for instance, like here, that's something you always see in the import menu, the possibility to get your, for instance, velocity volume or your depth, time or depth interpretations from Petrel to OpendTect back and forth.
Yeah, thank you.
All right, thank you, Jafar. And we were able to get the question in from Marcelo. He was wondering if we would have the webinar available online, or if we would be distributing it in any way. And yes, every month we post the webinar online about 2 days afterwards, so you can expect a notice in your email on Friday, most likely, that the webinar is posted online. You'll be able to watch it online or download it and watch it directly from your computer. Now
yes.
Go ahead.
I would like to add that a lot of tools that are used in order to actually build the velocity model are in the volume builder that was presented at last month's webinar. So I would strongly recommend you to first have a look at this webinar done last month before you review this month's webinar on VMB, because they are very closely tied together.
Okay, and we've had one question that was typed in just a moment ago. I forwarded that on to you, Arnaud.
Yes.
So if you would read that aloud for everybody.
Yes, so the question is if I can elaborate a bit more on the pre-processing method and how you can use the VMB plugin to do velocity corrections. So actually what you need to do, this is a brand new window, and so the first thing you would always do is pick mute definition, especially if you have a data set like this. And the next thing, the very first next thing, what you see, the curve in black is an overview of the move out at the position of the mouse. And so it only gives you an overview. And once you see, so what you do actually when you're picking, you simultaneously keep an eye both on this black curve and on the Semblance panel before you actually make your pick. And only when you have a good agreement between your gathered data and the Semblance data, you can decide to pick. And then you make a number of picks here, and the addition tools are very much the same as in all the picks that's in OpendTect. So a left click will place a seed. Then if you hold the left click, you will move the seed on all directions. You can add additional seeds. You can, with control left click, you'll remove a seed, and so on. On the fly, on this gather display, you have a quick tool to get an overview of the velocity correction on that CDP. Okay. And then automatically in the settings, there is a settings that is such that every time that you change your CDP location, so every time you move to another CDP, the RMO function will be updated. So then you'll get a set of velocity peaks that will need to be converted using the volume builder velocity grider step into your new velocity volume. And this is something you may want to do with either inverse distance weighting or triangulation, depending on the geometry of your peaks. And here you would retrieve your velocity peaks in this setup. We don't have, as I said, you don't have much to do in this step. You only have to retrieve your data. So these will be your gridded velocity peaks. And that will form the first step of the volume builder setup. So now, then this step can be applied on the fly by adding a special layer of type volume processing attribute on your inline. So now I'm back in the 3D scene. I've added this special kind of layer called volume processing attribute, and here you can select the setup that will actually grid your velocity peaks. And here, well, I didn't pick much traces, so it doesn't give much. You really need to do this on a large number of CDPs, like this in this example, where I have gridded delta peaks. So these are the peaks you have just made. I've just made in the previous panel. Now, in order to go a bit further and to do the move-out correction, you will need to specify this setup in the velocity correction menu. And in order to do this, let me first do it on a PreStack data store. So I've made a right-click on the slice, and that is showing me the PreStack gathers perpendicular to the inline position. Now, in the right-click menu of this common image gather display, I can go to the properties, and the last tab can be used to apply pre-processing on the fly on this common image gather. So in this case, you can choose to do, for instance, mute and AGC. And if I press apply, as you can see, it will apply the mute and the AGC. Or you can go a bit further and apply the mute, the AGC, and the velocity correction. And that will, as you can see, with the additional step velocity correction, whose only input is the new velocity volume. So with this only additional input, you can have now move-out corrected CDP gathers. And this setup, this pre-processing setup, can be saved and retrieved at any time. And that is something you could use in order to make a new full stack or partial stack data store by using the basic attribute called PreStack. So I'm now in the attribute set window, which is available from the analysis menu. Reading that is a basic group, the attributes is called PreStack. This is where you can input your migrated data, and in that case I'll retrieve the setup that consisted in applying the mute and the AGC and the velocity correction on that PreStack data store. And now you can choose to output all offsets, or for instance you could restrict the offset range and get a near stack. So this is a near stack seismic after RMO correction. And this attribute is defined and is like any of our OpendTect attributes. This is only a definition. So far nothing has been computed. I've only specified all the input data and all the jobs, all the computations that must be performed. and in which order they have to be performed. And now this attribute, let me dismiss the PreStack display. This attribute can be applied on my inline, for instance. That was the full stack of the migrated PreStack data store, and you can go here and get the near stack after the sole application of mute, AGC, and the move-out correction without further migration. That is a very, very important workflow because, as you can see, by only specifying a few pre-processing methods and picking a very limited number of move-out corrections, you can increase the quality of your full stack or near stack data tremendously. Okay. And then if you go for an horizon-based update, as you can see, it will be much more easy to interpret your horizons on this pre-processed data than on the initial migrated PreStack data store and the corresponding post-stack data. Okay, so this illustrates what I mentioned at the end of the rather end of the workflow, that you can apply the velocity correction on the gathers without remigration.
Thank you, Arnaud. We have another hand raised, so we have one more question. Jafar, you're unmuted. Hello?
No, I don't have any questions. Yeah.
Oh, your hand was raised. Okay.
Yeah.
Okay. All right. Well, thank you.
Thank you.
Okay. I'll give a few more minutes for people to send in questions, but in the meantime, I would like to thank everybody for attending. I would like to thank Arnaud for his very detailed presentation. This is going to be very useful, and as I said before, it will be available online. We'll send out a link to that at the end of the week, and this will definitely be a good one that you can go back to and watch a few times to really get the workflow down. Now, next month, we will be having synthetic to seismic matching and correlating wells with Farouk. Farouk will be presenting that on the 11th of January, so we'll send out a registration link for that in about a week or so. So please be watching your emails for that. And the announcement for this webinar online will be found first of all in the LinkedIn and the Facebook pages, simply because those are immediate releases, and when they are sent out through the user's mailing list, it has to go through approval. So if you're really antsy, really ready to get the webinar link, then just keep an eye on the LinkedIn and the Facebook pages and you'll be the first to know. So thank you everybody for attending, and we look forward to seeing you next month. Have a good day, everybody.